Hi, in this video, we are going to discuss some PYQs for circles chapter. So we have done the theory in the previous two videos, and we'll start with some questions today. So the first one is this one. Let a circle passing through 2, 0, passing through 2, 0, have its center at HK, have its center at H, K. Now let xc, yc be the point of intersection of the lines 3x plus 5y equals 1 and 2 plus c times x plus 5c square y equals 1. If h is equal to limit of c tends to 1 xc and k is equal to limit of c tends to 1 yc, we have to find the equation of the circle. So very simple question. This is JEE Mains 2024. So we have XC comma YC is the point of intersection of these two lines. So let's solve that. So 3x plus 5y equals 1 and 2 plus cx plus 5c square y equals 1, right? So multiply the first equation by c square and subtract. You will be able to solve for x and y. X will come out to be c minus 1 by, so x comes out to be here 1 minus c square by 2 plus 3, 2 plus c minus 3c square, and y comes out to be c minus 1 by 5 times 2 plus c minus 3c square. So this is simply by solving the two equations, nothing major here. Now find the limit of x tends to 1, c tends to 1 for xc. That would be c tends to 1 here. This is actually coming in 0 by 0 form. So do L'Hopital's rule. So minus 2c by 1 minus 6c, and put 1 now, minus 2 by 1 minus 6, so minus 5. So this is 2 by 5. And limit of c tends to 1 for yc is also 0 by 0. So it will be 1 by, after L'Hopital's, 1 by 5 times 1 minus 6c. So put 1 here, you get a minus 1 by 25. Now the question has said that h and k were the values of these limits, and hk was the center of the circle. So now that we have the center of the center of the circle is coming out to be 2 by 5 comma minus 1 by 25. It is very easy to now find the equation of the circle, because first of all, center is known and another point is known. So we can easily find the radius. The radius will be the distance between 2, 0 and this point, right? So calculate the radius and write the equation of the circle in the standard form. The equation of the circle will look like this. You have x minus 2 by 5 whole square plus y plus 1 by 25 whole square is equal to radius square. And radius will be calculated by doing the distance formula between this point and this point, right? So very easy question, simple limit application, and then straight lines you have to solve, right? Let's move on to the next problem. Question number 2. In this question, it says, let the center of a circle passing through 0, 0, 1, 0 and touching the circle touching the circle x square plus y square is equal to 9, be h comma k. So the center of the circle is h comma k. Then for all possible, values of h comma k, h and k, find out what is 4 times h square plus k square. So it's like saying find out the locus of h comma k, or the relation between h and k, right? So we have a circle with center h comma k. The equation of the circle will be x minus h whole square plus y minus k whole square is equal to r square. Here h and k are unknowns, and we have it touches the circle, touches x square plus y square is equal to 9, right? So basically, two circles can touch each other either externally or they can touch each other internally like this, right? These are the ways in which they can touch each other. So what we do is we can say that the distance between the centers C1, C2 will either be equal to R1 plus R2, or it will be equal to basically R1 minus R2 mod, right? So we will use that condition. We also know that this circle passes through 0, 0 and 1, comma 0. So let's put that first. We get h square plus k square is equal to r square, and it also passes through 1, comma 0. Here I have put 0, comma 0 in the circle equation. If you also get 1, comma 0, you'll get 1 minus h whole square plus k square is equal to r square, right? That is the second point that lies on the circle. So from these two equations, we can easily say that h square plus k square is equal to 1 minus h whole square plus k square. And from here, we can say h square is equal to 1 minus h whole square. So h is equal to plus minus 1 minus h. So h is either 1 minus h or h is minus 1 plus h, but this is not possible. So h is 1 minus h. So 2h is equal to 1 and h is equal to half. So we get this information, h is equal to half. And we also know that h square plus k square is r square, and this is equal to r square, right? Technically, we have this equation now. 1 by 4 plus k square is equal to r square, right? Now we will check the condition that C1, C2 should be R1 plus R2 or should be R1 minus R2, right? So what we have is the distance between the centers. One of the centers is h comma k. The other center of this circle is 0, 0. So C1, C2 square is equal to h square plus k square, right? Okay. And that will be either R1 plus R2 square, which will be 3 plus R whole square, or it will be 3 minus R whole square, right? H square plus k square will either be this or this, correct? And from here, now we should be able to figure out stuff because we already know this relation, right? And now we have another relation. H is, so we have 1 by 4 plus k square, because h square we already know is 1 by 4, is equal to 3 plus r whole square or 3 minus r whole square. So we will use each case, we will solve and see what comes. So 1 by 4 plus k square, we already know is r square, is equal to 3 plus r whole square. In that case, we get r is equal to plus minus 3 plus r. So if you do plus, it doesn't work. So you get r is equal to minus 3 minus r. So you get 2r is equal to minus 3. So it doesn't work at all. Both the cases are not making sense. So we'll use the other case, 3 minus r whole square. So now you have r is equal to plus minus 3 minus r. So if you do the plus sign, you have r is equal to 3 minus r. So 2r is equal to 3 by 2. So r is equal to 3. So r is equal to 3 by 2. And if you take the minus sign, you have r is minus 3 plus r. That doesn't work, right? So finally, we have gotten the r value as 3 by 2. And therefore, h square plus k square was equal to r square. We already had this equation. So therefore, from here, we can say h square plus k square is equal to r square, which is 9 by 4. So 4 times h square plus k square is equal to 9. right? And that becomes the answer to this problem. Again, not very difficult. All you had to do was take a general circle equation and then check whether 0, 0, 1, comma 0 lies on the circle, and what is the condition for two circles to touch each other. The condition is either C1, C2 is R1 plus R2, or it is mod of R1 minus R2, right? We checked all the conditions. We got the value of H, K, and R, right? So that is our problem. Let's move on to the third problem, question number 3. Here we have circle equation C1, x minus alpha whole square plus y minus beta whole square is equal to r square, and C2, which is x minus 8 whole square plus y minus 15 by 2 whole square is equal to r2 square. This was r1 square, this is r2 square. And they say C1 and C2 touch each other externally at the point 6, 6, right? Now, the question is, if 6, 6 divides the line C1, C2 internally in the ratio 2:1, you have to find out alpha plus beta plus 4 times r1 square plus r2 square is equal to what? Again, a very easy question. What we have is two circles. They are touching each other externally at a point C1, C2, at a point 6, 6, right? And this is C1, this is C2. I will draw the figure again differently because C1 to C2 internally, the ratio was 2:1. So we have a situation like this. This is C2, this is C1. This was 2 and this was 1. And this point is P, which is 6, 6, right? And C2 point, center of C2 second circle is already known. It is 8, 15 by 2, right? Center of C1 is not known yet. It is alpha, beta, right? But actually, now you can find out the point alpha beta directly because we know section formula, and C1 C2 line is being divided in the ratio 2:1 by the point 6, 6. We already know the C2 point, so we can find C1. Let's say C1 is alpha beta. We have these relations by section formula. We can do 1 into alpha plus 2 into 8 by 3 is equal to 6. And similarly, we can do 1 into beta plus 2 into 15 by 2 by 3 is equal to 6. So from here we get alpha plus 16 is equal to 18. So alpha is 2. And from here we get beta plus 15 is equal to 18. So beta is 3. So automatically now I know the center of the first circle. Simple section formula. The center is 2, 3, right? Great. If I know the center, I can find the radius also, right? Notice that point P lies on both the circles. So 6, 6 is the point on both the circles. So radius of this circle is going to be basically 6 minus 2, 4 square plus 3 square. So this is 5. And the radius of this circle would be basically half of that. So it should be 5 by 2. We can also check here. It will be 4 plus 9 by 4 root over. So this becomes 25 by 4, so 5 by 2. So the radius of the two circles are 5 and 5 by 2, right? And therefore, alpha plus beta is 5 plus 4 times r1 square is 25 plus r2 square is 25 by 4. So basically you have 5 plus 100 plus 25. So 5 plus 100 plus 25 is 130. And that becomes your answer here, right? So that is the solution. And it was a pretty easy question. It was a question based on external touching and basic section formula. The best way to approach such questions is to always try to draw a figure. If you draw a figure correctly, then you will get the hang of the question, right? All of the questions that we are discussing today are JEE Mains 2024. So you should realize that actually the questions coming in JEE Mains are not very difficult, especially in this chapter. A circle is inscribed in an equilateral triangle of side length 12, right? If the area and perimeter of any square inscribed in this circle, if the area and perimeter of any square inscribed in this circle are m and n, then find out the value of m plus n squared. Again, a very easy question. You just need to know what is the meaning of inscribing something inside a figure, right? So this is my triangle. Circle is inscribed inside it. That means it is the in circle, right? This is an equilateral triangle and this is an in circle, which basically touches the three sides, right? So now you know from standard properties that the centroid, in center, everything is the same point. For an equilateral triangle, centroid is equal to orthocenter, is equal to circumcenter, is equal to in center. All the 4 points are identical, right? So technically, if I draw a line like this line is perpendicular to the other side, it will divide the base, right? And this point G will be centroid and will also be the center of the circle, the in center. So now we can easily say that the height here, this is also an altitude. So this is going to be root 3 by 2 into A, and centroid divides the median in the ratio 2:1. So this part should be 2 and this part should be 1. So therefore, this part is 1/3 of root 3 by 2 into A. And that becomes the radius of my circle. So 1 by 2 root 3A. That is the radius of my circle, in circle. If A was the side of the equilateral triangle, right? Now we have an in circle here. And now we have to make a square inside this. We have to inscribe a square in this circle. So if you draw a square like this is the situation. And the square will be symmetric like this, 90° every side is equal. And this will be the diagonal, and the diagonals are perpendicular, and this is the center of the circle. So notice that the diagonal is equal to the diameter of this circle. So since we already know the radius, the diameter has length what? Twice of the radius, so a by root 3. If the diameter is this, root 2 times the side is a by root 3. So that will give us the side of the square. Because the diagonal of a square is root 2 times the side. So we get side of the square is a by root 6. If this is the side of the square, the area of the square m is going to be a square by 6, right? And the perimeter of the side square n will be 4a by root 6. So n square is what? It is 24a square by 6, right? Correct. So m plus n square is coming out to be 25. Basically, a square by 6 plus 24a square by 6. So you're getting 25a square by 6. And what is a? A was given as 12. So it is 25 into 12 into 12 by 6. So basically you get 50 into 12. So that is 600. And that will be your answer. 50 into 12, right? I feel like I have made a mistake somewhere. Uh, the radius is correct. A by 2 root 3 is correct. Uh, so the square side has length root 2 s is equal to a by root 3. So side length is a by root 6. That's correct. Area of the square is a square by... Oh wait, I'm making a mistake. No. A by root 6, a square by 6. A square by 6 is coming out to be 12 square by 6. So 24 is the m. That's correct. And 4 times, oh wait, 4s, 4a by root 6. So 4 times a, which is 12 by root 6. So this is coming out to be 6 into 2 here. So 2 into root 6, so 8 root 6. 8 root 6 is coming as this. So square of this will be 64 into 6. So that will be 64 into 6. So I'm making a calculation mistake. 64 into 6 will become 384 plus 24 should be 408. That is my answer. When I did right now here, m plus n. Oh, I am making the mistake here. Notice here. Square of this is not 24. It is 16 a square by 6, right? So we are getting 16 a square by 6 plus, so it is 17 a square by 6. So that was the mistake. You should get the answer as 408, right? The problem was really easy. We just have to know how to do inscribing, how to inscribe a circle inside a triangle, a square inside a circle, and so on, right? Okay. The next question is, let C be the circle of minimum area touching the parabola, y is equal to 6 minus x square, and one and the lines y is equal to root 3 mod x. Then which of the following points lie on the circle? Which of the following points lie on the circle? And the options given to us are: A is 1 comma 2, B is 1 comma 1, C is 2 comma 2, and D is 2 comma 4. So now this is a question where you need to draw the diagram correctly. Then only you will get the idea of how to do it. So let's first start by drawing the parabola. Notice that it is a parabola y is equal to minus x square plus 6, right? Y is equal to minus x square would have been like this. And plus 6 would be shifted above by 6 units, right? So I will just draw it on this screen. So this is my situation. This is my parabola. And this is y is equal to 6 minus x square. And this point is when x is 0, y is 6, 0 comma 6, right? This is my parabola. Now, what are the lines y is equal to root 3 mod x? So there are two cases here. One is root 3x when x is greater than 0. And one is minus root 3x when x is less than 0, right? So minus root 3x will be a 60-degree line like this. And root 3x will be a line like this. This angle is 60, and this angle is also 60, right? So now I have to make a circle of minimum area that touches these three things, the parabola, and also touches these lines, right? Okay, so maybe my circle looks like this, something like this. And it touches these lines and it touches the parabola as well, right? Okay, so the circle has to have minimum area also. By symmetry, it looks like the center of the circle will be somewhere here, right? How can we be sure? We know that 0 comma 0 is the point of intersection of the two tangents to the circle, right? So perpendicular from here and perpendicular from here will be the lines passing through the center, right? What do I mean by that? So I have this line here. This is a tangent, right? So whichever point of tangency is there, from there you can draw a line perpendicular to the tangent, and that line should pass through the center, right? So the line perpendicular to the tangent here would be y is equal to minus 1 by root 3 x plus k, right? Why is this line perpendicular to the tangent? Because I have put the slope as minus 1 by root 3, right? Similarly, for y is equal to minus root 3x, the line perpendicular to the tangent would be y is equal to plus 1 by root 3x plus k2. And if this was k1, both of these lines should pass through the center of the circle. So the intersection point of these two will give us the center. Now you can easily see here, if I subtract these two, I'm getting 0 is equal to x by root 3, so plus, so 2x by root 3 plus k1 minus k2, right? So I'm getting x is equal to something, x is equal to, is coming as k2 minus k1 into root 3 by 2. And at that moment, the y, okay, so we are getting this. Uh, this is the x coordinate of the center. I want to show that k1 and k2 are equal. Okay. Also, I can make a tangent at this point. The tangent to the parabola at this point would be the line y is equal to 6. So the line perpendicular to the tangent would be x is equal to 0. And therefore, since this is also tangent, the three tangents can only intersect on the y-axis somewhere, right? So what I can figure out from here, from the perpendicular lines intersecting, we know that the three tangents are meeting at the center, which is a point on the y-axis. So the center of a required circle has to be on the y-axis. So x is 0, and let's say the other coordinate is some k. This is the center of a required circle. So equation of the circle would be what? It would be x square plus y minus k whole square is equal to r square, right? Now this circle is touching the parabola at the point 0, comma 6, right? And it also touches the two lines, right? So we have to make sure that y is equal to root 3x and y is equal to minus root 3x are tangents to this circle, right? Okay. So for that, and this line for y is equal to 6 to be tangent, what we can do is, because y is equal to 6 is a tangent, I know the radius of the circle is simply, if this point, notice, if this point center was at k and this was 0, comma 6, this is the radius. So therefore radius is equal to 6 minus k, right? So I can write k as 6 minus r, right? And therefore the equation of the circle is becoming x square plus y minus 6 plus r, y minus k is 6 minus r, whole square is equal to r square. This becomes the equation of my circle. And now I will check the fact that y is equal to root 3x is tangent to the circle, right? So for that to happen, the perpendicular from the center, and the center of the circle is 0, comma 6 minus r, perpendicular from here to this line should be equal to length r, right? So I will do that now. It will be 6 minus r by 2 is equal to r, right? with a modulus. So I'll get 6 minus r is equal to 2r. So 3r is equal to 6 and r is equal to 2. That is one case. And you can do the minus sign also, but that doesn't give us a valid answer. So r is equal to 2 is coming, and the equation of the circle becomes x square plus y minus 4 whole square is equal to 4. That is the equation of my circle. And now you can verify which point lies on the circle. So this was a slightly more complicated question. What we had to do here was realize, first of all, by drawing the graph, that the center of the circle will lie on the y-axis. And if you think about the three tangents are y is equal to 6, y is equal to root 3x, and y is equal to minus root 3x. From there, you will realize that if the center of the circle is at 0, comma k, the radius of the circle is 6 minus k, right? So we wrote the equation of the circle like this, and then we converted everything into terms of one variable r. And then we use the fact that this circle equation is tangent to this line by finding the perpendicular distance between the center to the line and saying that that must be equal to r. And that helps you find the equation. Right. Okay. Now, the next question. It says let ABCD and AEFG be squares of side 4 and 2 units, respectively. The point E is on the line segment AB, is on AB, and F is on AC. The radius of the question is then the radius R of the circle passing through F and touching the line segments BC and CD. BC and CD satisfies which equation? The equations are given. R is 0, 2r square minus 4r plus 1 is 0. 2r square minus 8r plus 7 is 0. And finally, r square minus 8r plus 8 is 0. Okay, so we have to draw two squares. One square has side 4 units and one square has side 2 units, right? And then we have to mark these points properly. So let's try to think about it. We have one square like this, ABCD. In this problem, it will be convenient if you choose your x and y axis like this. Choose your y axis like this, x axis like this. So A will become 0, 0. This square is side 4 units. So this is 4, comma 0. This is 4, comma 4. This is 0, comma 4, right? The point E is on AB and F is on AC diagonal. And you have, this is my diagonal, and AEFG is a square, right? So we can have a situation like this where this is my square, EFG, and this has length of 2 units, right? So therefore the point E will be 2, comma 0, and this point would be 2, comma 2, and this point will be 0, comma 2. Now we have our figure, radius of the circle that passes through F and touches the line segment BC and CD. So BC is here, CD is here. Circle that passes through F and touches the line segment. Something like this, right? This is my situation. Correct. So what you should realize here is the center of the circle will lie. If you drop a perpendicular from here, center lies on this line, and a perpendicular from here, center lies on this line, right? Because it touches. So R and R are here. And basically, you will get center of the circle somewhere here. And the distance OF is also R, right? So I will draw the figure in this way here. So you have OF is R, this is R, and this is R. And the circle passes through, touches, and like this, right? This is my circle. This is F, E, A, B, C, and D. And this will be G, right? So if you think about it, this was 2, comma 2. And the center O clearly lies on the line y is equal to x, right? So we should know that this distance is r. So the x coordinate will be 4 minus r, and this distance is r. So y coordinate is also 4 minus r. So I'm getting the center of the circle is 4 minus r, 4 comma 4 minus r, right? And also I know OF distance is equal to radius. So I can say OF square is equal to radius square, and OF square will be 4 minus r minus 2 whole square plus 4 minus r minus 2 whole square is equal to r square. So you get 2 times 2 minus r whole square is equal to r square. This becomes 4 into 2, 8 plus 2r square minus 8r is equal to r square. So you get r square minus 8r plus 8 equals 0. So if you do simple geometry, draw the figure and exploit the symmetry of the problem, you will realize that because of the tangency of these lines, center lies on the diagonal and F lies on the center. F lies on the line through the center. So you get coordinate of the center as 4 minus r, 4 minus r. If you don't draw the figure, the question could be quite long because you don't have any other way to figure it out, right? You will have to write equations and all. You don't want to do coordinate geometry when you can do the question by pure geometry. That will always be faster. Okay, let's move on to the next one. It says, let the circle C1 with equation x square plus y square minus 2 times x plus y plus 1 is equal to 0. And C2 is a circle with center at minus 1 comma 0 and radius 2. If the line of the common chord, basically if the common chord of C1 and C2 intersects the y-axis at P, find PC1 square, the distance between P and C1 whole square, right? A very easy question based on theory. Let's first write the equation of circle 2. It is x minus minus 1, x plus 1 whole square plus y square is equal to 4. Expanding it, it becomes x square plus y square plus 2x plus 1 minus 4. So you get the equation as x square plus y square plus 2x minus 3 equals 0. This is the equation of C2. Equation of C1 is already given, x square plus y square minus 2x minus 2y plus 1 equals 0. Now, the theory is that common chord equation will come if you do C1 minus C2 equals 0. You take the two circle equations, make sure that their x square and y square terms have the same coefficients. and then subtract them to get the common chord equation. So if you do that, you'll get minus 2x minus 2x minus 4x minus 2y, nothing. So minus 2y plus 1 minus minus. So plus 4 is equal to 0. So the equation is 4x plus 2y minus 4 is equal to 0, or 2x plus y minus 2 equals 0. That is the equation of my common chord, and it intersects the y-axis when x is equal to 0. So when x is equal to 0, y is clearly 2. So the point P is 0, comma 2. And the center C1, the center of this circle is obvious. It is 1, comma 1 minus g minus f. So the distance PC1 would be 1 square plus 1 square. So root of 2 and square of that is 2. So the answer is 2. And this question is actually very easy. You just need to know whether you know the equation of common chord or not, right? Okay. Let's move to the next problem. It says, let C be a circle with radius root 10, with radius is equal to root 10 and center at origin. Let the line x plus y equals 2 intersect the circle at points P and Q. Intersect the circle at points P and Q. Let Mn be a chord of C of length 2 units, be a chord of C of length 2 units and slope minus 1. Then the distance between the chord PQ and chord Mn. Then find the distance between chord PQ and chord Mn. Another question where drawing the figure is the most important thing. So let's look at the circle. Circle is like this. X square plus y square is equal to 10 is the equation of my circle, right? Center is the origin. Now the line x plus y is equal to 2 is a line like this. It cuts the circle at 2 points, P and Q. The slope of the line is minus 1. Slope of this line is minus 1, right? This is my line, and I have another chord of C of length 2 units and slope minus 1, right? So this is another chord with slope minus 1. So this is going to be a parallel chord, right? So let's call it M and N. The length of this chord is 2 units, correct? And this is the center of the circle. Now I have to find the distance between the chord Mn and the chord PQ, right? So first thing I will do is I will find out the length of chord PQ. Length of chord PQ. How do I find that out? I can drop a perpendicular from the center of the circle to the line PQ. That will give me the distance of C from this. And I know already the radius of the circle R. So by Pythagoras theorem, I can find out this, right? So the perpendicular length is basically perpendicular from 0, 0 to this line. So it will be 0 plus 0 minus 2 by root 2. So that is coming out to be root 2. So this distance is root 2. Radius of the circle is root 10. So therefore this distance is going to be by Pythagoras theorem root of 10 minus 2. So root of 8. So 2 root 2. So this much is 2 root 2. So the length of the full chord would be 4 root 2, right? Correct. Now I know this distance is root 2, and actually the length of this chord was not necessary for solving this problem. Now that I think about it, I can write the equation of this line mn, because I know that the length of the chord is 2. So therefore, perpendicular from here to here will be here, and this length will be 1, right? And this is the radius. So radius is root 10. So I have a triangle like this here. This is 1, this is root 10. So I can find out this distance, right? So it will be root over 10 minus 1. So root over 9. So this is 3 units, right? So I know that this is 3 units, and I already know this much is 2 units, root 2 units. So the distance between the chord PQ and chord MN is simply 3 minus root 2. Actually, it's a super easy question. You don't even need to find this. You just need to draw the diagram and know one basic result from geometry, that the perpendicular from a center to a chord bisects the chord. And after that, it's Pythagoras theorem. So far what I'm seeing is most of the questions in circles are based on geometry facts, basic 10th standard geometry. Many of the questions are based on that. So far, we have not encountered too many questions which are related to the circles theory that we have done. However, we'll continue to do more problems. We will also do questions from JEE Advanced, because so far JEE Mains seems to be a little underwhelming. The questions in JEE Mains are quite easy, right? However, that will be the focus of the next video. We'll do more videos on problems on circles, so stay tuned for that. Please like the video and subscribe to the channel. I have seen that many of you are watching the videos but are not subscribing to the channel. If you subscribe, you'll get notified of any future videos and series that we will be launching, right? So please do subscribe and help me grow the channel. Share it with your friends and in your groups. I appreciate all your support. We'll try to finish the circles, more problems on circles in the next couple of days, and then do straight lines as well. I try to finish the coordinates geometry series by the end of this week. So that's it for this video. I'll see you next time.